Okay, so for this FRQ, we're going to be working with a chart. So the directions say the temperature of water in a tub at time t is modeled by a strictly increasing twice differentiable function W, where W of t is measured in degrees Fahrenheit and t is measured in minutes. At time t equals 0, the temperature of the water is 55 degrees. The water is heated for 30 minutes, beginning at time t equals 0. Values of W of t at selected times t for the first 20 minutes are given in the table above. Part A says use the data in the table to estimate W prime of 12. Show the computations that lead to your answer. Using correct units, interpret the meaning of your answer in the context of this problem. So we're given a chart for W of t, and we want to find W prime of 12, which means the slope. So I'm going to be finding the slope at 12, which is between 9 and 15. So I'm going to find the slope between those 2 points since they're the closest to 12. So for part A down here, I'm going to find the slope. I'm going to subtract my y value, 67.9 minus 61.8, divided by, now I'm going to subtract my x values, 15 minus 9. So that gives me, and I'll give you a second, go ahead and pause the video and calculate that with your calculator. This is a calculator enabled question, as all of your FRQs will be this year. So we want to make sure that we round to 3 places, so that's 1.017. Now the second part of A says, using correct units, interpret the meaning of, oops, sorry, I'm in the wrong part. Part A says, using correct units, interpret the meaning of your answer in the context of this problem. So what this means is we just found a rate, right? Because we found the slope. Slope is the same thing as rate. So this is the approximate rate that the temperature is increasing at 12 minutes. So I'm going to write that down. This is the approximate rate that the temperature is increasing at t equals 12 minutes. Okay, next is part B. Use the data in the table to evaluate the integral from 0 to 20 of W prime of t dt. Using correct units, interpret the meaning of that in the context of the problem. Okay, so we're going to take the integral from 0 to 20 of W prime of t dt. So we're taking the integral of a derivative, which means it's just W of t, and we're evaluating that from 0 to 20. So when we evaluate, we do top minus bottom, so W of 20 minus W of 0. And those two pieces of information I can get from the chart. W of 20 from the chart is 71. W of 0 is 55. So basically, I'm just subtracting the ending temperature and the beginning temperature, which is 16. So 16 degrees. So what that would mean in the context of the problem is that's how much the temperature increased from 0 to 20 minutes. Next, we're going to do part C. So part C says, from 0 to 20, the average temperature of the water in the tub is 1 over 20, the integral of 0 to 20 W of t dt. Use your left Riemann sum with 4 subintervals indicated by the data in the table to approximate this value. Does this approximation overestimate or underestimate the average value of the water over these 20 minutes? Explain your reasoning. Okay, so let's start with our left Riemann sum. Now there's one extra part in front here, and that's 1 over 20. So we're going to be finding the average of our answer when we're done. So I'm going to go up to my data here, and I'm going to start with my left Riemann sum. So I'm going to start with the first set. The base of my rectangle would be 4. I'm going to leave this 1 over 20 out in front, so 4. The left height is 55. The second rectangle, the base between 4 and 9 is 5. My left height is 57.1. From 9 to 15, my base is 6. My left height is 61.8. And then from 15 to 20, my base is 5. My left height is 67.9. Okay, so now you would pause, go ahead and figure out that number, and then don't forget to divide by 20. Okay, so that answer is 60.79. So we have to answer if this is an overestimate or an underestimate. So what we want to look at, let's take a look at this data here. If I plotted this data, 0, we're at 55. 4, we're at 57. It's increasing. So let's say it looks like that somehow. Now I'm doing a left Riemann sum. So every time I do the left side and cut back over, those rectangles, when I add up all the areas together, they actually would be less than the area that would be the actual area. So a left Riemann sum actually under approximates the area for this one. So we would say it's an under, and you don't have to use complete sentences, an under approximation. Now we want to use calculus to explain this because W of t is increasing, and a left Riemann sum would sit below the line. Okay, last part is part D. Part D says, for 20 to 25, the function W that models the water temperature has first derivative given by 0.4 times the square root of t cosine of 0.06 t. Based on the model, what is the temperature of the water at time t equals 25? Okay, so we have a rate. We want to know the actual temperature, and we want to know the temperature at 25. So I know the temperature for the first 20 minutes from the chart up here is 71. So I'm going to take that 71, and add it to all the temperature that I get for the next 5 minutes. So if I have a rate and I want to know the actual temperature, I'm going to go backwards by taking the integral, and I'm going to go from 20 to 25 of this function. Now this is a calculator question, so I'm going to use my calculator, but you want to make sure you write down what you're plugging in your calculator, otherwise you won't get all the credit. So I'm going to go to my calculator and type this in. So let's see if I can pull it along the side here. Okay, so I want to calculate this integral here. So I'm going to go to Menu, Calculus, number 3, integral. And I'm just going to type in the 20 to 25, 0.4 square root of, I'm going to use x, cosine of 0.06 x dx, and then I'm going to add that 71 to it. So in the last 5 minutes, the temperature only went up about 2 degrees. So my final temperature, though, is 73.043. Okay, so that concludes this last FRQ.